Assalamu alaikum, dear students. In the name of Allah, the most beneficial, the merciful. As I am teaching to my children, so I have decided to share the same with of similar standard students. This time I am sharing the first lecture of mathematics of class 10. The contents of the books are complex number, quadratic equations, matrices and determinants, linear and quadratic inequalities, algebraic fractions, functions and graphs, vectors and plane, application of trigonometry, chord and arc of a circle, tangent and angle of a circle, practical geometry of circle, and basic statistics. Today, I want to give a concept of the chapter 1 related to complex numbers. Some questions from exercise 1.1 will also be solved here. Don't worry. The whole solved questions and the whole exercise and the whole chapters will be uploaded on the page. So let's start the concept. From this page, my name is Engineer Muhammad Shoaib. I have did my B and ME in engineering. First of all, to uh, define the complex number system. So the complex number system was not so much aware to the scientists up to 16th centuries, because up to 16th centuries the scientists or the mathematicians were only familiar with the real number system. In the real number systems, that was rational numbers and irrational numbers. The rational numbers was written in the form of p upon q, where p and q belong to the integers and q does not is equal to 0. It means that all the integers, the natural numbers, the whole numbers, all these numbers are the rational numbers. So rational numbers the is considered as a ratio. So all these numbers and the ratios that is written in the form of p upon q, but q will not be equal to 0, is the rational numbers. And the numbers other than the rational number is called the irrational numbers. For example, 2, square root 2, square root to 7, and pi, the value of pi. These are non-terminating values and non-recurring values. So these are called irrational number. So the combination of rational numbers and irrational numbers are called real numbers, and all the calculations, the arithmetic calculation, will be carried out upon these two type of numbers. The smaller sets of numbers are integers, in which the negative and the positive values are mentioned. The subset of the integer is whole number, which is started from 0, 1, 2, 3, and the subset of whole number is a natural number that is started from 1, 2, 3, 4. So we can the points to be remembered for real number system is the natural number is the subset of whole number, and whole number is a subset of integers, and the integer is the subset of rational numbers. Another things is to be remembered, that is the real number is equal to the rational number plus the irrational numbers. The complex number consists of both the real numbers and the imaginary numbers. The concept of imaginary numbers came after the 16th centuries, when the numbers, the negative numbers and square roots, under square roots, the negative numbers, when the solution was not possible. So in that case, the mathematician decided to introduce a new numbers that is called the imaginary number. For example, x square plus 2 is equal to 0. So x square is equal to minus 2 and x is equal to square root equal to minus 2. This was not possible. So the new things, that is the iota, was introduced after 16 centuries, and it was the combination of that imaginary numbers, which is actually the product of real and imaginary, that is iota b, iota 8. So in the iota b is the real number, iota is the imaginary numbers, and both of the product is called the imaginary number. So it is introduced after the 16th centuries. So in after the 16th centuries, the imaginary number was introduced. So a new number system, that is called complex number, was um, developed and defined as the combination of real number plus imaginary number. So we can say the complex number is real number plus imaginary number. Here we have to introduce two conditions. If b is equal to 0, this complex number become the real numbers, and if the real number becomes 0, and a is equal to 0, then the complex number become the pure imaginary number. Here I have to solve some of the questions, and the for example, if someone asked to express each term in term of iota or iota y, so in this case, if the question is in the form of square root minus 5, so first we converted, we divided the minus 2 into minus 1 into 5, and minus 1 minus 1 is equal to the iota square. It is supposed that iota square is equal to minus 1, so it is understood. So we put the value of minus 1 in the questions, and then the number become iota square root 5, which is pure imaginary number, because the real number is not exist here. So in case of non-existence of real numbers, the numbers become pure imaginary number, and if we added the real numbers, then it's become a complex number. Another question from the exercise 1.1, question number 1, part sub question 2, 6 and 2 square root minus 4. So again we put the value of iota, which is equal to iota square is equal to minus 1. So again it will be become this, and the answer will be 12 iota. Again question number 2 of exercise 1.1, sub question 1, 4 minus iota plus 5 plus 5 iota. It is the addition of complex number, so we add real with real and imaginary with imaginary, and the answer will become 9 plus 4 iota. Another type of question, that is question number 3, that we have to convert iota 13 into some smallest or simplified number. So iota 3, as we know that iota square is equal to minus 1, so we will try to some power up iota 2. Iota 13 will be divided into iota 12, and iota 12 will be further arranged as iota square power 6, so it's become 12. So we put up putting the value of iota square minus 1, and then the it will become iota. Another thing, that is simplify in the form of iota a plus b iota, any in the form of complex number. So minus 17 plus iota 5, again iota 5 will be divided into iota and iota 4, and we put the value of iota 2, so the answer will become the minus 17 plus iota. The last question of the exercise 1.1, that is question 5 sub question 1, 3 upon 4 minus iota. So the in the numerator 4 minus iota is a complex number, so the conjugate of this complex number is 4 plus iota. So we multiply and divide on the conjugate of the 4 minus iota, that is 4 plus iota divided by 4 plus iota. So again the numerator will be multiplied and the denominator will also multiplied with each other. In the denominator, it's become a formula a plus b into a minus b is equal to a square minus b square, and then we apply the formula and multiply in the numerator and apply formula on the denominator. Then we putting the value of iota square, that is -1, and then after some calculation we get the value 12 plus 3 iota divided by 17. So 17 is in the denominator. It is dividing both the 12 and 3 iota, and in the simplified form you will get this answer. So this is a quick overview and some concept that I want to convey to you, and the whole exercise will be solved and be uploaded on the page as well as on my WhatsApp, on my YouTube channel, that is Federal Academy. So please, if you satisfied with the lecture, please follow and like the page for my appreciation. Thank you.